In this video, you're gonna learn divisibility concept using Vedic maths.
You know, every now and then you come across an idea that's so clever, so elegant, you just have to wonder, why don't they teach this in school? Well, today we're going to unlock a mathematical secret that turns a ridiculously hard problem into something you can actually solve with just a pen and paper. It's pretty amazing.
So, get a load of this question. Is this massive 10-digit number divisible by 739? Oh, and the main rule? No calculators allowed. Not your phone, not a computer, nothing. So, where would you even begin? I mean, it seems completely impossible, right?
And that's really our puzzle for today. How in the world can we tackle a division problem that looks this intimidating without a machine to do the heavy lifting for us? Well, the answer, it turns out, isn't about brute force. It's about a little bit of ancient mathematical magic.
The key is this beautiful technique that comes from Vedic mathematics. It's called the Ekadhikena Purvena Sutra. Now, it's a special method designed for testing divisibility for numbers that just so happen to end in a 9, kind of like our divisor, 739.
The name itself is just fascinating. Ekadhikena Purvena. It translates to, by one more than the previous one. Honestly, it sounds more like a line of philosophy than a math formula. But that simple little phrase, well, it's the entire instruction manual we need to solve this thing.
So, to unlock this method, we first need to find ourselves a secret key. And in this system, that key is a special number with a very cool name, the osculator. This is the tool that we're going to use to shrink that giant number down to a manageable size.
And finding this osculator is, believe it or not, super simple. We just follow the instructions in the name. Multiply by one more than the previous one. We take our divisor, 739, and we just drop the last digit, the 9. That leaves us with the previous number, 73. Then, all we do is add 1. So 73 plus 1 gives us 74. Yep, it's that easy.
And there you have it. Our osculator, our secret key for the number 739 is 74. This is the number that's going to let us test for divisibility without ever doing any long division. So, you ready to see how it works? Okay, now we can begin what's actually called the osculation process. This, right here, is where the magic happens. We're going to use our key, the number 74, to repeatedly shrink our massive starting number, again and again, until it's small enough to actually deal with. The rule is really simple, and we're just going to repeat it over and over. You take the very last digit of your number, you multiply it by the osculator, that's our 74, and then you add that result to the rest of the number. The reason this whole trick works is that this process cleverly preserves the divisibility. Each step creates a new, smaller number, but the answer to our big question, is it divisible by 739, that stays the same. All right, let's put it into action.
Okay, here's our big number again. Remember this beast? Let's apply our rule for the very first time. We're going to focus on that last digit, the 6. So, first step, we take that last digit, 6, and multiply it by our osculator, 74. And that gives us 444, a nice, simple multiplication to start us off. Next, we take that result, 444, and we add it to the rest of the original number. You know, the whole thing with that last digit just chopped right off.
And just like that, we have our new number, 529,324,453. Now, yeah, it's still huge, of course, but look, it's one digit shorter than what we started with. We've officially completed one cycle. So, what now?
You guessed it, we do the exact same thing again. Our new last digit is a 3. We multiply it by our good old osculator, 74, which gives us 222. And we're going to add that to the rest of the number. And there we go. Our next result is down to 8 digits. Now, we're not going to walk through every single one of these steps on screen, but you get the idea. You just keep repeating this process. Take the last digit, multiply by 74, add to the rest. You do this 17 times in total, and that massive number shrinks down to something, well, tiny.
So, after all that shrinking, after applying the osculation process again and again and again, where do we finally end up? What's the final number that gives us the answer we're looking for?
46. That's it. After 17 steps, that 10-digit monster, 5 billion something, has been reduced all the way down to just 46. It seems almost unbelievable, but that's our result. The big question is, what does 46 actually mean?
Well, here's the final and most crucial piece of the puzzle. For the original number to be divisible by 739, our final result has to be one of two things, either 0 or the divisor itself, 739. Any other number, and it's a no-go. It's not divisible.
And here is that big aha moment. Our result was 46. To be divisible, it needed to be 0 or 739. And while 46 is pretty clearly neither of those things.
And there we have it, the definitive answer to our impossible puzzle. 5,293,240,096 is absolutely not divisible by 739. And the best part? We figured that out without doing a single bit of long division.
But, we should probably ask, can we really trust this ancient magic? Of course, we should check our work. So let's finally pull out that calculator we weren't allowed to use before and see if modern technology agrees with our ancient sutra.
And there's the proof in the pudding. When you actually punch it into a calculator, you get a whole number, sure, but you also get a remainder of 362. And as we all learned back in school, if there's any remainder at all, it's not perfectly divisible. The ancient method was spot on.
It's just an amazing example of how sometimes the most elegant and powerful solutions have been around for centuries, just waiting for us to rediscover them. It really makes you wonder, doesn't it? What other incredible secrets are just hiding out there in plain sight?